how do we solve for x if we're given x squared equals 49? We have to get x by itself. If we rewrite this to look like x times x, what times itself is going to be 49? Most of you are probably going to say 7, and 7 does work. 7 times 7 equals 49. But we also might realize that there is a second answer to this. The other answer would be negative 7. It's for this reason that when we look at solving a problem like this, and we use a square root to get x by itself, it generates two possible answers. So let's look at this using the square root. Taking the square root is an inverse operation of squaring a number. And if we remember, 2 is the index for the square root. And you don't see him at first, but he's really hanging out there. And this 2 and this 2 are what's really canceling. So the square root cancels the squaring, giving us just x back. And then when we take the square root of 49, a lot of our calculators just say 7, which is called the principal. But we also know from this demonstration that it could also be negative 7. So the symbol that we use is a plus on top of a minus sign, and we read this as plus or minus 7. This is the same as saying x equals 7, comma, negative 7, and then a lot of times you see these curly brackets used to show that this is the set of answers that you have. So now let's look at this in a problem-solving scenario. Alright, so now I have something more involved here. I have x minus 3, and all of that is squared, and that equals a number. We're going to use the same procedure. I'm going to take the square root of this side, and if I take the square root of this side, I have to take the square root of this side. And so this square root is canceling this squaring, leaving me just this value here, the x minus 3. And then we take the square root of 100, and this is going to be plus or minus 10. We want x by itself, and we would like to subtract or add 3 to this side. But there's really two answers here. So one thing that you can do is set up two cases. Since this means you have a positive 10 or a negative 10, we're going to set it up first as case 1, the positive case. And case 2 is going to be the negative case. So notice the thing on the left-hand side remains the same. The only thing that's changing is the thing on the right-hand side to represent the two different values here. So we're looking at solving x here when we have a positive 10 and solving for x here when we have a negative 10. So since this is x minus 3, I'm going to add 3 to both sides. Add 3. When I add columns, x plus nothing still gives me x. Negative 3 plus 3 gives me 0. I don't have to write the 0. I'm going to add 3 here, so I have 10 plus 3 is 13, and that equal sign stays between. So we have x equals 13. Over here, we're going to do very much the same thing. So my two answers for x for this problem is x is 13 or x is negative 7, and I'm going to write that with some curly brackets. This is my answer set. Let's look at another problem. So at first, this does not look like the two problems that we just did. I have this expression on the left, I have a single number on the right, I have a square term here, there's no variables anywhere else. Number one rule for problem solving in algebra is to get everything that has the term you're interested in on one side, everything that doesn't have your term onto the other side. We're solving for m, so I want m over here. We're going to move everything else away. So I'm going to add 151 to both sides to get the 151 to go away. 2m squared plus nothing is 2m squared. Negative 151 plus 151 is 0. I'm also adding 151 onto the right-hand side. Now I'm going to divide both sides by 2. Again, I'm trying to get m by itself. And now I want to take the square root of both sides. So this is going to be m. So I have m equals, the very precise answer for this is going to be 5 square root 2. If you plug this into your calculator, you're going to get some kind of a decimal answer here. So it's an approximate answer, it's not an exact answer. So you can do that. This is an exact answer. The instructions here are to factor out the greatest common factor. So I want to ask myself, what can I divide both this term and this term by? That's the same term that I can divide both by. Well, one thing you might notice is that I can divide 3 by 3 and get 1, and I can divide 27 by 3 and get 9. So 3 is definitely one of those terms. So I'm going to make a note to myself right here. 3 divides both of these. The other thing you might notice is that I have a y in both places. Y also divides this. So now I'm going to use this note to self as a part of my solution. I'm going to add some empty parentheses here, and I'm going to go through and I'm going to divide each term by this greatest common factor. So I'm looking at this divided by this, so out to the side, if you want to look at what I'm doing, I'm reducing this fraction. So what happens when we have 3 divided by 3? We get 1. Y squared divided by y, well, this is the same as 3y times y and 3y. We can go through and just mark off things if that's the way that you like to do this. And I have just one y left. So the answer to this is y. So that's what I'm going to put in here. When I take this and divide by this, I just have y left. And likewise, this term divided by this is going to be the negative 27y divided by 3y. And then I can mark off my y's. And then I can look at the negative 27 divided by 3 is negative 9. So that's going in the bracket here. This can be helpful in problem solving. If this original problem had been equal to 0, that means that these two terms should be equal to 0. Now, what's something special that we know about terms that are multiplied and we get a 0 product? Over to the side here, just any real number a times any real number b equals 0. I should know that either this is 0, or both are zeros. This is called the zero product property. Now, I said a and b are real numbers, and you probably want to see that. So let's just randomly choose a is going to be 5, and b is going to be 0. The product of that is 0. But what if a was the 0 and b was, say, 7? Again, and then the other option would be that they're both zeros, and we get 0 times 0 is 0. So this is our zero product property. If in my original expression it was an equation equal to 0, and I have this term now times this term equals 0, this is playing the part of the a, this is playing the part of the b, and so one of these has to be 0. So in solving a problem like this, once we have it set up with the product of the common factor and whatever was left over, let's say that we believe that a is equal to 0. What would that make the y here? Well, the thing that we can do is we can solve for y. So divide both sides by 3. We get y on this side, and then 0 divided by 3 is 0. All of a sudden we know that y, the missing value that we had, is 0. What if we assume that b was our 0? Well, that means that y minus 9 had to be equal to 0. What does y equal? Well, we're going to add 9 to both sides. And we find out that y is equal to 9. So, if I plug 9 into here, I have 9 minus 9 is 0. 0 times 3y is 0. That works. So this tells me that I have, again, two solutions. I got plus or minus here because we know the square root of 50 is either going to be a positive or negative value. And then up here I had the two values, x equals negative 7 and x equals 10. So let me rewrite this one here as a set of answers. I have the positive 5 square root 2 or the negative 5 square root 2. That is my solution set. So down here, my solution set is y equals 0 or y is equal to 9. We're looking at ways to factor quadratics, some independent variable to the second term. And we are also looking for solutions to these problems, in this case 0 and 9 for this final problem. But that's only assuming that we knew this started out as 0 first. If you don't have this equal to 0, we can't use the zero product property. So let's look at an example where this doesn't start out as 0. Alright, looking at this problem, we're going to solve for x. So the first thing that I want to do is I want to get a 0 on this side, because that's how I'm going to use the zero product property. So how do I get 0 over here? Well, I simply subtract the term that's over here so that I have a 0. So if I do something to the right hand side, I have to do that to the left hand side. So I'm going to subtract 24x over here. And so I'm going to have 4x squared minus 32x over here. Is there a common factor that I can pull out of both of these? Since both of these are even, we should know that a 2 will come out of there. Since both of these have an x, we should know an x should come out of there. So let's try that. I'm going to divide this term out of just these things. So 4x squared minus 2x, and if you want, I can make a little note out to the side here. I have 4x, so that's x squared, and I have 2x here. So I mark out an x, mark out an x. 4 divided by 2 is 2, and I have 1x left. So that's 2x. Alright, and then I want to look at negative 32x divided by 2x. Now I want you to notice something. This still has a factor of 2 in it. This is an even number, so I did not factor out the greatest common factor. Sometimes you don't always see the greatest common factor. We simply can just pull out another factor. So the 2x is already here, and I'm going to write a multiplication sign there, and then I'm going to write the factor that I want to pull out, the common factor of 2 in both of these. And then I'm going to put parentheses again, and I'm going to go through and divide each of these by 2. So now on the outside here, I need to multiply these two together. 4x is the greatest common factor. And so that's how you fix that if you didn't pull the greatest common factor out the first time. It's going to be my a term and my b term. So if a is equal to 0, that means 4x is equal to 0. Divide both sides by 4. X is going to be 0 itself. If this b term was our 0, b equals to 0. So my two possible answers are 0 and 8. As a solution set, I have 0 and 8.